Yes, so now the recording is enabled and let me start the session. So first thing is last time I covered functional programming in Java, and what I used to demonstrate it was Jupyter Notebook, right? I guess Shrikant, you would recall, and yeah, others can watch the recording to see how I was sharing various Java APIs through notebooks, right? So notebook is a content or is kind of a worksheet where you can put some markdown textual description commentary about your code, and notebook is a kind of a REPL environment. A REPL environment is it's you know something which can execute the code in real time. It's like a shell where you can run various programming commands, which includes SQL, which includes Linux commands, and which includes also using some scripting or other language commands. So for Java it uses JShell. It can also execute Python code. It can also execute some other languages as well. So some kernels are available in notebooks. Similar notebooks could be utilized to learn and execute Spark commands, right? So you can run, download any Python library, play around with it. So there is something called Python Pandas. So has anyone heard about Python Pandas?
Nope.
Okay. Pandas is basically a library which is for analytics and data processing, right? So what you can do with Panda library is, if you have a CSV file, you can import it to your Python runtime, and you can run various SQL kind of commands on these CSV files. So it's like working with SQL, very similar to working with SQL, but instead of a relational database, you can work with the CSV file and run various APIs, which could be filtering, querying on the CSV data set which you have.
I have used it.
Okay, great. So what was the use case? If you can just share, that would be great.
It is more of data processing. To run any AML kind of algorithms, right? You first read the CSV file, bring it into a data frame. Once it is available in memory, then you can do a lot of manipulation of those. For example, if there is any data correction that you want to do, or identify any uh, statistics of that, right? Like mean, median, mode, or any of those typical statistics. Pandas library will be helpful for that. Yeah, I used that.
Yes, absolutely. Okay, great. Okay. So yes, pandas run your command on a single cluster, correct? In the Python runtime. Yes. Uh,
Yeah.
Spark can do distributed processing. So similar is Spark. Spark is for data processing. It can work on very large data set because it can partition the data and distribute this data into multiple clusters, and there are multiple workers. So in Spark you have multiple workers, and you have there is a cluster manager also, which is like a Kubernetes cluster manager, or there are different cluster managers available. Even Kubernetes can be used to manage the clusters of Apache Spark, and then various workers can work on the independent data sets, right, into various data sets independently, and it can give the results very quickly. So that's the advantage of Apache Spark, right? So so there are few things to learn in Spark. It's first thing is Hadoop is almost like obsolete these days. People are preferring Spark. Spark is almost similar to Hadoop. The only difference is in Hadoop, the data operations are done in the disk, but in Spark, the data operations are done in the uh, in memory, right? So it's sometimes it could be even 100 times faster than Hadoop. So this is about Apache Spark, exactly same as Hadoop, and Apache Spark only difference is the way it manipulates the data. It does all the processing in memory. So yes, Spark requires little bit more expensive infrastructure. Hadoop can run on disk-based infrastructure, which is slow, which is cheap also. It is slow and but yes, it could be cost effective as well. But yes, most of the time these days, companies prefer having Spark over Hadoop because infrastructure is now also available on cloud in AWS, Google, or Azure, and Apache Spark could be run in any of these clouds. So yes, cost is not a big factor here because any organization can pay the subscription. So this is about the primary use case of Spark. Okay, so now I will introduce you to an environment which is called Google Colab. So what I'm doing in this session, we'll do some hands-on exercise so that you know how to install and how to do some queries, etc. with Spark. So what I have is a environment which is called Google Colab, right? So I'll introduce you to that. Just a minute. Let me start from scratch. I have done already some work on that. But Google Colab is a cloud-based notebook, right? I already talked about uh, Jupyter Notebook. In Jupyter Notebook is Python originated notebook, and yes, here I have a environment which is Google Colab, which is a cloud hosted version of Jupyter Notebook. So if you are not familiar with Python, it may be difficult for you to install Jupyter Notebook or set up Jupyter Notebook. But no worries, we have this freely available tool which is called Google Colab. So here if you see, this is a worksheet, and this can contain text, and good thing is this is like a document, right? So if you see here, there is a document. It says welcome to Google Colab because this is a getting started worksheet. You have some videos, and yeah, you have someone has any
Yeah,
questions?
are we sharing the screen? Because I'm not seeing anything.
Okay, sorry, then I forgot to share the screen because yes, just a minute, let me share.
Sure.
Yes, okay, so let me do a quick recap because yes, I missed sharing the screen. So now I think everyone is seeing a screen, right?
Yeah. Yeah.
Right, so you see here, welcome to Collaboratory. Okay, this is a tool. How do you go into this is you just type in here the URL collab.research.google, right? So this URL is something which we should note down. I'll put this in the chat message also so that it is there for for you, so that you can also open if you want. You can run it side by side. So here it's like Google Drive. So yes, I will go to this screen. So here you see there are some video, there's some web page kind of content, right? So this is, and then there is code also, right? So here this is seconds in a day, and good thing is that this code could be executed like Jupyter Notebook, right? So when you click on this play button, it will execute the code and give you the result. So it's executing and then it gives you the result, right? So this is how you can do. You can edit it. Say for example, if I just say here 100, and this is all in the real time, it's executing the code, right? So now you see the result has changed. So you can run Python programs here, and with little bit of configuration you can run other languages as well, but by default it support Python programming languages. So here you see that okay, there is some graph visualization also done using this. So this is nice tool for data analysis, and this could be shared also with the other people. So for example, I can click here and share it like Google Docs. It's having all the features of Google Drive. So we'll use this to work with Apache Spark, right? So let me create a new notebook here. I click new and go to new notebook. So it will start a new notebook for me. Okay, I'm just waiting to get the new notebook. So you see here, this is my notebook. Notebook is my workspace. I can run some Linux command. So to run Linux command, I put the exclamation symbol first and then put ls, and then again click the play button. So I will see, my folder structure. So you get a kind of a virtual machine here, and this is not your local machine, it's a virtual machine. So I see here some sample data folder, and I can keep clicking on this code. So plus code will create a new code panel here, or here at the bottom also you have code or text. So I can say text also. When I say text, I can put some text here. For example, I will say, right? So I can run markdown. So you have a editor which can be used to run which can be used to kind of create some documentation also in the real time. So now coming back, okay, I can run some more commands here, pwd for example, and then I'll put this with a exclamation. Great. So you see here that print current working directory is also executed, and you can rearrange these items. So this is about Google Colab tool. Now let's start installing here Spark, right? So yes, this is, I showed how to run shell commands, Linux commands. I can also try running some Python command also. So for example, in Python, let's say we have some variable, let's say sum, and we say 10 into 5, and we execute it. So it gets executed, nothing is printed here because we are assigning it to sum. So what we can do is we can just create another code, and we can say here sum, right? And we can print sum like this. Okay, and let's execute this. So it printed the value of sum. So whatever you are doing, it's there in the environment, it's loaded in the virtual machine. So this sum variable is coming in the next cells also. So it's not that you have used one line and you cannot reuse. You can reuse it, every variables or anything, any package you import, you can use it in the rest of your worksheet. Okay, so this is about simple Python code and how to run it in a notebook which is within the Google Colab notebook, and it can it saves the file in format Python notebook format, which is a format also used by Jupyter notebook. So you can export this, run locally on Jupyter notebook or the vice versa. So this is about Google Colab, and it's a very user-friendly tool for data scientists or programmers. Now let's start installing Python Spark, right? So so the way to install this is let me have some more shells. I can rearrange it. or I can remove things. So let me put down here, and to install I will run this command pip install Python Spark. And if I run this command, pip is like in Node.js you have npm. In the similar way in Python you have pip command. So when you run it, it will start installing Python. So it's now installing Python in my notebook in this particular worksheet. So I'm seeing this is installing and there is a progress bar, and it should finish in few minutes, the installation. And once it's installed, we can test it out that whether our installation is successful or not. So the package build is completed. Now installation is successful, and you got the latest version of PySpark, which is the Spark's latest version is 3.3.1, right? Yes. So just to show you what is the latest version of Spark, and you can also install it manually also, but yes, this is Apache Spark homepage. And if you see here, this page has some information about what is Apache Spark. So it's a multi-language engine. Okay, yeah, this I should cover few of the basics about Spark. That Spark, as I said, is an engine for executing commands or processing data, right? So it can, the use cases are in analytics, in data science, in machine learning. It can run on single node or it can run on clusters, which we covered already. I shared that could be running, it can run on clusters in cloud environments like AWS, Google Cloud, or Azure. And at the same time, it can run on single node on a machine as a single instance, or you can have a cluster in Kubernetes, because you don't need multiple servers. There could be small clusters which could be managed by Kubernetes as well. And these are the key features that can do streaming data processing. It can also have batch command execution, and it can do analytics using SQL queries, and it can do data science at scale. That, generally the volume of data could be GBs of data, right? So if you are using a relational database, I would say up to 2 GB or 5 GB data table size, your relational database will be good. But if the data size is bigger, then the performance will deteriorate. So you can't scale the relational databases beyond multiple GBs. But here, if you have 5 GB of file, you can process using Spark. And you can apply some training algorithm also. And this could be run with so you can create a, say, recommendation engine. If you have an e-commerce site and you want to create a recommendation engine, that could also be done using Apache Spark. So this is about, and this is about Spark. And then you see here, this is the installation command PySpark, which I executed within Google Colab. So I have not installed anything on my local machine. It's all done in the cloud, in Google Cloud. And then you can load the data here and apply various queries on that to do the data analytics. It also supports other languages, which is SQL, Scala, Java, and R. So these are various other languages which is supported by Spark. And this is the reason for its popularity, that it supports all the languages which a data scientist would be familiar with. It's easy to use. it is having Java. So yeah, this is the command if you want to run in Docker, and then you can kind of follow this instructions to run the command. So here you have some getting started information for various languages. Uh, so yeah, this is one of the reason for its popularity, that it's easy to use, it has a lot of libraries, and it's similar to other languages like Pandas or Scikit, TensorFlow. These are various other libraries. So there's a good ecosystem of libraries and tools which you can use within Spark. And it's open source, free to use. So this is all about the fundamentals of Apache Spark. Coming back to our worksheet here. So we have installed it. It's saying successfully installed, and this is the latest version. Because if I go to the downloads, I see this is 3.3.1, which was released maybe just 10 days back, October 25th, 2022. So this is the latest Apache Spark version which we are using. And now let's test this environment. So I have got it. Okay, we can verify this by running some Python commands. So I can say from PySpark.sql import Spark session, right? So you can run this command. So it will import Spark session. Then I can say I'll create another code output. Say Spark equal to, I'll paste some code. So this is I'm creating a new Spark session, right? So this is the Spark session dot builder dot master, and then I pass here what's the name of the master, and then I just run the command, run the function get or create. So this is running and creating a Spark session. Okay, it's executed. I see the tick mark here. This means this is executed. I also see how much time it took. It took 7 seconds. And then I say can create one more code just to print the property of what is the content of variable Spark. So I can just use Spark. I don't need to also use the print command. It just prints out the details of Spark. So this verifies your installation of Spark in your notebook. Great. Any questions up till now? Pretty straightforward, simple. Yes. So now Spark is up and running and we have it installed in the notebook. Important thing to note is if I leave this notebook, right? If I don't use anything, so here I'm just running some commands. So my session is live. I see that RAM and disk usage also. Here is statistics. But yes, if I leave it like this and go for coffee and get it disconnected, no, it will automatically get reclaimed by Google because this is a virtual machine. So I need to then, in that case, what I need to do, this is stored. All my commands will be stored, so I will have the history. But my runtime environment will be gone. So I have to re-execute it. So if I leave this and after some minutes I come back, maybe say half an hour, and if I try to use Spark, I'll not see the Spark installed in this virtual machine. It will be reclaimed because my virtual machine will be switched off by Google due to inactivity, right? There's a free service available. I don't have to pay any cost. So that's why the session is reclaimed, and just to kind of optimize the resource, Google will turn off the server. But yes, no, I can just come and quickly reinstall this, and then I'll again back with my Spark environment. Okay, now let's try some other commands here. So this is now if you do this, you're all set to use Apache Spark, and then you can execute a lot of things in Apache Spark. Okay, so something more I can share is there's open data uh, project, right? So you can search open data, because very important thing is how can you find lot of information. So here if you see, this is data.gov.in. So here you will see lot of information about some data which is released by Indian government and on which you can do some analysis, right? So for example, you see here there are a lot of data is available here in this site. The idea of releasing all these data is government wants to allow people to do some data analysis and come up with their applications and come up with reports, and this can help in decision making also, right? So just to show you how can you get some data, so here you have various data sets. So let's take some data into various areas. You have here data available. So for example, let's look into some data, something which could be interesting. See, so many for agriculture data is there, then economy, power and energy, industry, travel and tourism, food. So yeah, we can take some use cases like for example, you are planning a trip or you're planning to stay in some area and you would like to know some information about maybe the maybe about police stations or crimes or anything. You can get some data set. So just I'm trying to see some data set if which could be interesting in this which is available free of cost, right? Let's say we take some education data set. Yeah, and then in this you have the APIs also. These are APIs available for the government from the government which you can use, and then these are the schemas, right? So if I go into the schemas, I'll see various information about. Okay, another way to browse is through the sector. Other way is to browse is through the location, state-wise. Yes, so here I will find more important data, right? So assume I just search the first Goa. About Goa, some data could be very interesting. Yeah. So here I see a lot of data available about Goa. Yeah, here I go to catalogs and right, so let's say here this crime in 2021. So there are data sets available here. Okay, it's loading. So just so state wise, and yeah, you see here there are various CSV files available. Correct? You can preview it. So this CSV file is about population data in various states, right? So it shows some records, first time records. So this way you can get a lot of data over which you can analyze and run some Spark queries, right? So you can download the CSV. Let's say we download this, and okay, it's asking other information inputs and all, but yes, with once you have the time, you can kind of register here, and then you can download this data, and this will be, you will get a CSV with all the information, right? So I'll use some data which I have already downloaded. So this is about the Indian government. Same you can find for US government also. So open data about, say, you want to know about New York, right? So you can just search here and then you will get city-wise data for US also. So here you have data available for other cities, right? So if you say some data about crime rate, right? This will be a lot of data. It will be GBs of information, because how many crimes were reported in New York. If you just look for that data, it will be for 1 year. It will be thousands and no, sometimes in hundreds or tens of thousands of reports of crimes will be there. So if you want to analyze this and figure out that, okay, what's the location where maximum crime are there, you can do that analysis and find out good analytics from this. So this is a few of the use cases which I would say are there for Apache Spark, right? So other thing what you can do is I will just share some notebook which I have already prepared, and will show how we can load the data and execute some commands on that. So just hold on, I'll just load a sheet. By now, any queries?
I used few datasets on the Kaggle.com, Tarun, just as a
Okay.
yeah.
So what kind of data sets are they? These
I primarily looked at the datasets where during the COVID times, right? There was a lot of
okay.
data that was being collected to
Yes.
understand what kind of mortality is there across age groups who have already some pre-morbidity factors, right? So I was trying to do some
Okay.
hands-on on those datasets. So Kaggle.com had good datasets there.
Okay. Great. And what's Kaggle? Is this a company? I see .com. So yes, is this some company which is working on data
I think,
science?
no, this is, I think, a arm of Google where a lot of, I mean, they launch some competitions where you can go and participate in those competitions and write code and then upload your thing there.
Okay.
So for example, if I had written some small pieces of code to do some predictions on some pricing for some online based on the historic data, right? What kind of pricing patterns are there, or to predict in this particular holiday season what would be the typical sales that could happen.
Okay.
Something like that. So they run some competitions. I had probably participated in one or two of that, but it has
Okay.
got good. The content is quite good there.
Great. I also see it's kind of a notebook environment, right? So
Yeah,
it's
it is.
also
It is. Yes, very similar to the Google Colab. Yeah.
yes. So great. Yeah, this is another alternate. Then I see that, okay, Kaggle could also be used to learn, how to analyze data set. But yes, no, you can explore on your own how to install Spark on this, and can you run Spark, and yeah. So is there free? If it's freely available, what's the limitation? So yes, you can see another environment is Databricks, right? So Databricks is another company which provides free environment where you can run Spark commands and you can play around with Spark. Now, this is also very important. You should all know Databricks is the parent company which created Spark. Or Spark originated from University of Berkeley, and then this project was donated to Apache Foundation. So from University of Berkeley, they did some research, they created this Apache Spark, and they published a paper, and they showcased that the performance of Apache Spark is much faster than Hadoop cluster. And then they donated this code for this library or this environment which they created to Apache Foundation, and a few of the members of the research group, they created this company called Databricks, and this company is providing enterprise support for Apache Spark, and it also provides a community edition of so you see here community cloud databricks.com. This is the free version of Apache Spark, which is running in servers hosted by Databricks. So it's a complete cloud environment available for free, but you get a smaller cluster. So you get 6 GB cluster here, but if you want unlimited cluster size, then you have to pay, and there is a subscription fees for that. So this is important site which you should be aware, because this is the parent organization for Databricks. So you can use the open source version, but commercial version of Spark is available through Databricks. Okay, now let me showcase how to load the uh, some data set. So I'm just opening some data set. Okay, so what I will do is I'll open another notebook, and which is from my desktop. So I'll choose a file from my local environment. Okay, so yeah, let's say I choose something. So I've loaded a worksheet. So yeah, this is a new worksheet, and what uh, I need to do here again is I need to uncomment it and install Apache Spark. Okay, this is another way of installing Apache Spark. It's doing step by step download of Java, then it's doing download of Spark, and then but it's using some older version, and then it's installing something which is called find Spark library, and then it's setting up environment variable, and then running some commands here, so which we did already. We created a Spark. So this is the same stuff, but yes, now since we know better way to do it, we can just comment it out, and we can just put here our command, which is just a minute. Okay, I closed it. So which could be, say, pip we say install PySpark. Okay, can you use here exclamation, because this is a shell command. So just I'm creating a new sheet, so I have to reinstall Python Spark. So once this is done, I don't need all this because if I'm doing installing the jars from different website manually, and then I have to set the environment variable as well. So I can remove this part also, and then this part we can run to test our installation in this new sheet. So so yeah, this is the command how they are kind of importing the data. I'll explain this next once my here my installation is completed successfully. So here let me create one more coding section. I think I should use pip install. Uh, this is what I'm using here is PySpark library. So I'll say PySpark. No, this I did already, but find Spark. This is what I'm using here. Find Spark library. So I'll use this command find Spark. Right. So as I said, this is like npm. So anytime you get a new library, you have to do pip install. Like you have to do npm install in case of Node.js, and then you have this installed successfully. And let me execute this again to see if this code works. Right. So yeah, you see here same thing, slightly in a different manner. They created PySpark Spark context, and then they say Spark context dot get or create, and then this we did exactly last time. That right. So you got inputs. So you see here, this is in memory. Spark session is created in memory, and these are the details. We have one master node, and we have the name of this cluster, which is called PySpark shell. If you have multiple clusters nodes, then you will get the list of these nodes here. So this environment is also now set up, and and this is the code which is which what it's doing is from PySpark. Okay, so here in this sheet, I believe we should download some data. So is showing something download. So we did install this, we set up environment, and then okay, this is about this, and this is running some commands. So what it's this command, this code is doing is it is getting functions. Functions is for stream processing. It can execute functional programming commands or libraries. Then import to timestamp column so here there is a file called reported crimes.csv. So let me see if I have this file here. So if I go to do ls command, and this file we have to download. So let's get this file also quickly. So to get this file, which is used in this sample code snippet, I go to Chicago data city site where there are various data which is available, and then I can search for, say, crimes in the city, some data around it. So yeah, these are the data which is available. So 2001 to present, let's say some data which is for 2020, right? This is, I think, available latest data set. And then I can say view data, and we can say download the CSV. So if I click on download CSV, this is one way of doing the download. Other way is here I will download and then I can use it. So that's one way of doing it. Other way is directly, since I know the URL, I can use this directly and get the download done from this particular URL itself. So let me try that. Copy. I will copy the link. So here I say this is the URL from where I should get this file. I think this command should get this file. Oh, sorry, there is a typo. Yeah, here I run. Yeah, you see here it's downloading the data. I have downloaded for Chicago for year 2020 the crime data. This is the actual data released by the government. It may take few minutes to download it because that could be a huge data. But once we get this file, what we can do is here we have spark.read.csv command which is running. So here we have to rename this file to say reported crimes.csv. This way, yeah, this download is over now. So let's say if I can see where this download has happened. Yeah, you see here this file is called this. It has given some strange name which is rows like this. So what I can do is I can rename it. So to rename it, let me create a code widget and I will run a command, move command, and this we can rename it to reported it's done, and we can verify it by just running and seeing. Yeah, see, now this file has been renamed. So I can rerun this command and it can show the first 5 rows of this command. So here I am importing this sheet, this CSV file. It contains header. This is what is being specified here. And then I'm running some query. So I'm saying date is to be filtered 2000 so something. It's asking for date which is 2018 11th of November. So I'll change it to 2020 because we downloaded for 2020 the data. So now if I run this, it should print me first 5 records from this CSV file. Yeah, you see here, you got this file 5 records, and you can run various queries using various functions which are available with PySpark. And you can get to know about all these functions from their documentation. So they have very good documentation available in the Apache Spark site. So here you can find all the functions and how to you have tutorials also to run the data analysis. So this is about the key use cases of Apache Spark and what you can do with Apache Spark. Right? So you can either run queries and figure out which is the area. So here you see some data that on 9/30, 17th of March, this was the date, and this is the area where some crime was there, and the type was theft. There are other types like motor vehicle theft or assault, right? So deceptive practice, narcotics, these are various types of crimes which has happened. Then there are descriptions about the crime and whether arrest was there or not. So all this information is available. Exact location with latitude, longitude is also available here. District number. So various details are there for this particular data set. So you can analyze it and figure out which areas have maximum amount of crimes, or know what type of crimes are maximum number, and then this is helpful for making for lawmakers to make decisions, and these kind of analysis could be done using Spark. So similarly, you can have some record of customer orders. You can figure out what kind of orders are being made by some type of customers, run some machine learning algorithm, also do some predictions or recommendations, and then feed the result back to your yeah, you can feed these results back to the application, and this way you can create a recommendation engine also. So this is all about what I will cover today. Any questions on this?
No, Tarun, it's been good. Pretty easy implementation.
Yes, right. So yeah, with respect to running SQL commands, there's no limit. You can use joins. You can import different kinds of data sets and find out correlations between that also, right? So maybe you can get the job data in a different CSV file and then run some analysis about what is the correlation between the crime rate and job data, or so this is another kind of data science analysis, because in data science these are the key use cases. Either you find the trends in an existing data, you can find the count of some type of data, or you can find the trend or correlation between different trends in different data sets. And then the third thing is you can feed these data, you can do transformations on these data also. For example, you have some data, you want to convert it into some different format. Maybe you want to remove some unnecessary columns, right? You can do that also. You can create a kind of a more concise data fragments. So here in Spark, uh, these are not information which is stored in table. There's no database in the background. These are stored as objects, Python objects. But you can do the SQL kind of analysis on this. So almost same operations which you can do on database, you can do on objects which are in memory, and you can make it sense out of it, and it is much faster than traditional relational database for data analysis. It's basically a big data technology, because the data could be millions and billions of records. So this is another fundamentals of Spark. Great. Perfect. So yes, in system design, if you are asked some scenarios which are like you are asked to design a e-commerce system, then what you'll do is you will fed all the records of all the purchases or orders information into some big data, and then maybe you can create a CSV file and store it in S3, and then from S3 you can pick the information about orders and run some machine learning algorithm on this using Python or using Java, using Scala or various languages which are supported, and feed it back to the environment. uh, and show some recommendations to customers also. So this is one way of implementing. But yes, since your data volume is large, so you have to do this fast analysis fast, so you can use Apache Spark. So your S3 information could be read by Apache Spark, and then through some code you will apply some information transformation, filtering, and you will process this information and then give it back to the application to show recommendation. So this is how in Amazon or Netflix or various others application, online application, you see recommendations for what items to purchase. So this is how Spark is utilized in recommendation engines, or you see analytics, or into various other use cases as well it's used. So this is all about Apache Sparks. Okay, thank you.
Thank you, Tarun.
Great, great. So you see you next week. Okay, so you can play around. So you can view the recordings. You can uh, use these, uh, you know, uh, these commands which I have demonstrated, and you can play it around and explore more about Spark going forward.
Great.
Okay, have a good day. Bye.
Thanks, Tarun. Thanks, Chief.
So just to show you what is the latest version of Spark, and you can also install it manually also, but yes, this is Apache Spark homepage. And if you see here, this page has some information about what is Apache Spark. So it's a multi-language engine. Okay, yeah, this I should cover few of the basics about Spark. That Spark, as I said, is an engine for executing commands or processing data, right? So it can, the use cases are in analytics, in data science, in machine learning. It can run on single node or it can run on clusters, which we covered already. I shared that could be running, it can run on clusters in cloud environments like AWS, Google Cloud, or Azure. And at the same time, it can run on single node on a machine as a single instance, or you can have a cluster in Kubernetes, because you don't need multiple servers. There could be small clusters which could be managed by Kubernetes as well. And these are the key features that can do streaming data processing. It can also have batch command execution, and it can do analytics using SQL queries, and it can do data science at scale. That, generally the volume of data could be GBs of data, right? So if you are using a relational database, I would say up to 2 GB or 5 GB data table size. I know your relational database will be good, but if the data size is bigger, then the performance will deteriorate. So you can't scale the relational databases beyond multiple GBs. But here, if you have 5 GB of file, you can process using Spark. And you can apply some training algorithm also. And this could be run with so you can create a, say, recommendation engine. If you have an e-commerce site and you want to create a recommendation engine, that could also be done using Apache Spark. So this is about Spark. And then you see here, this is the installation command PySpark, which I executed within Google Colab. So I have not installed anything on my local machine. It's all done in the cloud in Google. And then you can load the data here and apply various queries on that is to do the data analytics. It also supports other languages, which is SQL, Scala, Java, and R. So these are various other languages which is supported by Spark. And this is the reason for its popularity, that it supports all the languages which a data scientist would be familiar with. It's easy to use. It is having Java. So yeah, this is the command if you want to run in doc, and then you can kind of follow this instructions to run the command. So here you have some getting started information for various languages. So yeah, this is one of the reason for its popularity, that it's easy to use. It has a lot of libraries, and it's similar to other languages like Pandas or Scikit, TensorFlow. These are various other libraries. So there's a good ecosystem of libraries and tools which you can use within Spark. And it's open source, free to use. So this is all about the fundamentals of Apache Spark. Coming back to our worksheet here. So we have installed it. It's saying successfully installed, and this is the latest version. Because if I go to the downloads, I see this is 3.3.1, which was released maybe just 10 days back, October 25th, 2022. So this is the latest Apache Spark version which we are using. And now let's test this environment. So I have got it. Okay, we can verify this by running some Python command. So I can say from PySpark.sql import Spark session, right? So you can run this command. So it will import Spark session. Then I can say I'll create a code output.